Okay, solution to worksheet 13 on EM spectrum. Okay, question 1. Microwave produces a frequency of so and so. What is the wavelength? Okay, answer is here. Okay, apply the V equals F lambda. We know that microwaves obey this equation, right? So find the wavelength equals to speed over frequency. Speed or the velocity, we know it to be 3 times 10 to the power of 8 because microwaves travel at the speed of 3 times 10 to the power of 8 meters per second in vacuum. The frequency is 10 times 10 to the power of 9 because 10 gigahertz is 10 times 10 to the power of 9 hertz. And you get 0.03 on the calculator, and with some play on the indices, it's actually the same value as 3 times 10 to the power of negative 2, and hence the answer of B for the wavelength. Okay? Okay, this one is, I think, self-explanatory. I shall not go through. Answer is A. Okay, question 3. Which of the following is correct? Wave P travels faster in air than Q. Okay, obviously P and Q cannot be both EM wave already, because we know that EM waves travel at the same speed of 3 times 10 to the power of 8. Okay, but because you see it's in air, right? Then you ask me, but is it 3 times 10 to the power of 8 meters per second in air or not? Actually it is. It's not much different in air and vacuum. So P and Q cannot be traveling at different speed. Answer A is out. Same thing for answer D. So which leaves us with B and C. Then you tell me, which one travel faster, sound or light? Do you hear the lightning first, or do you see do you hear the thunder first, or do you see the lightning first? We see lightning first, right? Which means light, or in other words, light, which is an EM wave, must travel faster than the sound, which is thunder. So wave P travels faster in air. It should be an EM wave. So obviously answer has to be B already. Okay, we don't even need to consider the shorter wavelength anymore. Q automatically is sound. Answer B. Next one. Okay, I've already listed here. This is not written in your notes, but I've just added in. In this sequence, highest frequency is ultraviolet, and so on. Okay, we need to compare P and Q in terms of wavelength, frequency, and speed. Okay, as seen, okay, let's go to the answers. A and B confirm out. Okay, these two are confirmed out because they tell us that the speed is different. Rubbish. P and Q, they are all in the EM section, the speed should be the same. So answer should be C or D. Okay, then we look at this description. P should have a higher frequency than Q. So let's look at A and B. No, sorry. P should have a higher frequency than Q. Right? Answer is C already. Okay? Frequency of P higher than frequency of Q. So automatically the answer must be C. There's no other option already. Okay? Answer C. Alright? And following question, answer is A. I think this is quite self-explanatory. You just compare the wavelength and frequency. Okay, for these two. Visible light and X-ray. Speed cannot be greater. We know that the speed is the same. And we have discussed the different purposes of the different EM waves. So this one is out. Answer is A. Okay, which of the following is probably the frequency of green wave? This green light, this is possibly the most difficult question of all. So let me bring you to we need to make some calculation. Okay, we will need to perform some calculation for this question to solve it. So let's see, you need to find frequency, right? We will apply the formula V equals F lambda and find frequency to be V over lambda. So all we need are the speed and the lambda. Green light is light, right? It travels at 3 times 10 to the power of 8. The speed is known to us, so no issue. What about the wavelength? Wavelength, I need to refer back to the slides. Okay, this one. Okay, in particular green light, right? Do you see that green light is somewhere in the middle of 700 nanometers for wavelength and 400 nanometers for wavelength? So we approximate the wavelength to be about 500 nanometers wavelength. And I'll substitute that into here. 500 nanometers times 10 to the power of -9. Okay, and the answer will be, let's calculate, 3.8 divided by 500, 6 times 10 to the power of 14 Hertz. Okay, and hence our answer A, question 6. Okay. Okay, this question, a laser pulse is sent from Earth. Laser pulse is part of EM spectrum. Okay, look at this slide. Where is it? Let me see. I saw it just now. I think it's under visible light. Yes, visible light, laser. Okay, laser. Laser is a type of visible light, so it belongs to the EM spectrum. Hence, the speed has to be 3 times 10 to the power of 8. We want to calculate the distance between the Earth and the satellite. If it takes 4.5 seconds for the laser pulse to be sent from Earth to the satellite and back to Earth. So this 4.5 times 10 to the power of -2 seconds is for the laser pulse to be sent from the Earth to the satellite and back. Okay, so it moved twice the distance. So let's apply the formula. Where is it? Okay, this is not relevant. Okay, we just apply the classic formula. They ask us to calculate what? Distance equals to speed times time. Okay, the speed we know for laser pulse 3 times 10 to the power 8. The time we know to be 4.5 times 10 to the power of -2. Okay, this value is 1.35 times 10 to the power of 1, 2, 3, 4, 5, 6, 7 to the power of 7. Okay, meters. However, we notice that the laser pulse travels twice distance from Earth to satellite back again. It travels 2 times the distance. So the distance between Earth and satellite, we must divide this by 2. 1.35. Okay, divide by 2. The answer is 6.75 times 10 to the power of 1, 2, 3, 4, 5, 6 meters. Okay, answer B. Okay, B. Sorry, B. Okay, let's move on. Okay, the structure questions are very easy. What is the transverse wave? Okay, I shall not spend more than 2 seconds on this. Let's move on. Speed of the waves traveling in vacuum. Okay, or for the above question, 3 times 10 to the power of 8 meters per second, because we're talking about the EM spectrum. Okay, list 3 consecutive components of the EM spectrum. The keyword is consecutive. Those of you who chose micro radio wave, infrared, and ultraviolet in this order, right? By right, I should not give you the mark. But I decided not to be so stringent on English. By right, it should be in this order: radio wave, microwave, or infrared. Okay, consecutive. Or you can give me microwave, infrared, visible light, one after another, not jumping, but maintaining the order. Okay, in order of increasing frequency. State 3 similarities between EM spectrum. Okay, go back. Okay, the answers are all here. Okay, on this slide. I don't think I need to give you much information now, except that I would, like I said, I do not like this answer. I prefer 1, 2, and 3. No, in fact, I prefer. There's a slight difference here. I think you delete 1, right? Okay, so it's deleted. Okay, I would prefer 1, 2, and 3 as the answers. Okay, these 3. Points 2, point 3, and point 2, 3, 4. Points 2, 3, and 4.